Hello, this is Ying-Dar. I'm glad to give a keynote in TridentCon this year. This topic is a series of work done with my PhD student, Asay Ali. And the topic is on federating cloud agent fork systems. We know that, if you have an account on Google, but you connect to AT&T, then you need another account on AT&T. But if they got federated, then you could use the service by AT&T without an account on AT&T. Okay, so that kind of idea of one account but service anywhere needs to be supported by this kind of federation. And when you do so, you need to do the so-called third-party authentication, which means that you need to authenticate with AT&T, which in turn connect to the second party, which is your home provider, say Google, so that you can finish the authentication. And that is third-party authentication between you as the first party and a foreign provider, which is in this case AT&T, doing the authentication on you. And because there will be so many combinations between a cloud agent fork, and totally there will be 24. In fact, there could be more if you, depending on the way you count. So we'll look at how many combinations we can have and how to solve all the federation problem. Okay. So I'm going to talk about some background on cloud agent fork, and then enumerate how many combinations we can have in the federation. Okay, and then we converge them into 7 problems. Okay, instead of 24 or more problems, we try to converge them depending on the type into 7 problems. And then we try to we take a general approach, which is called proxy and token-based approach, in order to solve them. Okay, and then we break down in the 7 problems into 3 groups. Okay, and the first group is between multiple MVC mobile edge computing system in 5G, and with the one intro operator, which means that 2 MVCs within the same service provider, or inter operator, meaning between different service providers. The second group is pairwise. We can have pairwise federation between cloud edge, cloud fork, and edge fork. And the third group is we try to be universal. Can we have universal proxy approach that will solve all of them? Okay, so we look at we take that approach and then try to solve 2 problems. One is cloud edge fork universal federation, and the other will be the more fragmented fork federations. Okay. So we know that cloud, edge, and fork, okay, they each have their advantages. So cloud is far away, big, with big computing capacity and storage capacity. On the other hand, the edge and fork, they are closer to the subscriber. And because they are closer, much closer, which means that they couldn't be centralized. They need to be pretty distributed geographically, so that the latency could be small. And in ETA side, they define edge as the service provider, like operator, like AT&T, Verizon, Orange. Okay, and fork being the subscribers to those service providers. So the fork node could be an individual UE, or could be corporate, or could be as big as a city government. But still, they are smaller than the edge. Okay, they are subscriber to the edges. Okay, and I know that in some community they use the term in the reverse way, where the fork is bigger and edge is at the bottom. But in ETSI, it's reversed. It's edge at the top, at the upper tier, and as operators, and fork as the as the service providers. Could be a small one or a bigger one. Okay, so we have these three type of computing paradigms, and well, the good thing to federate them together is to have best of the all worlds, which means that you could have each taking the advantage of each. For example, when the latency is not that critical, but capacity is, then you utilize the cloud. Okay, but if vice versa, then you use the edge or the fork. So for the subscriber's perspective, from a subscriber's perspective, it would be nice if I have just one account, but I can use any service, service anywhere in this under this federation. Okay, so to the subscriber, it's nice to have. But for the provider, how about for the provider? Yes, it's still, well, they can extend their service or the coverage. For example, Google one day will become the tenant to many providers, many operators worldwide, because Google does not have a facility close enough to the subscriber, to the users. So they need to rent the capacity from operators worldwide. Similarly, well, the AT&T does not have infrastructure outside United States. So if they can leverage Google, they have worldwide coverage. And if they can leverage Google, through Google, they can leverage Orange. Okay, they can leverage the infrastructure that Orange has in Europe. Okay, so you can see that among them, they could be renting capacity from each other in order to extend their service. Okay, so that's a right way to go if we build a federation in order to integrate them together. And so take this as this figure. You can see that I have 3 cloud at the top tier, and then some edges at the middle, and then a fork in the bottom, and the fork could be as small as a UE, okay, or bigger with the fork site with the computing facility, and then at the bottom it would also have UE, okay. And as I said, the fork node could be a corporate or a city government, or just an individual users. Now, as an example, we see that well, if I have an account on Google, but now I connect to AT&T, okay, and I do not have an account on AT&T. So then there'll be 3 parties here. That the first party is the UE, okay, and the second party is the home provider. I mean, where I have an account, and then the third party is the foreign providers, where I don't have an account but I'm connecting to, okay, and that's third party, and I need to be authenticated by the third party, and the third party will need to connect to my second party in order to retrieve my account information, and then verify I have an account there. And since they've got federated, there must be a way for them to talk in this way. And also, so that is called third party authentication. Also, if I move from one site, okay, one site to another, I move to here, okay, I have mobility, okay, and I'm running some computing here, but I move, and I want my application to continue seamlessly. So I need state transfer. I need to transfer the state from one MVC site to another MVC site. So and well, that transfer needs to be also done when I have mobility support. So these are the two issues we want to address. One is third-party authentication, and one is state transfer. Okay. So now let's count. Okay, why there are so many combinations? Okay. For possible federation. Okay, we can look at horizontal, vertical, and hybrid. Horizontal means that it's the domains or the providers are at the same tier. For example, cloud to cloud edge, fork. Okay. And vertical means that they are the federation providers in the federation are at different tiers. Okay. And hybrid means they have horizontal and also vertical in the federation. So for example, under the vertical, I can have one-to-many or many-to-one. One-to-many means that the upper tier has only one provider and lower tier have multiple providers. And many-to-many is reversed, where upper tier has many, but lower tier has one. So look at the two-tier structure. Well, you have ECE, which means that edge, cloud edge, the cloud in the middle at the top. Okay, and connect to two edges. Okay, and these two relationships are vertical for sure, and the one being upper tier is there's only one, and it's the cloud. Same here, you can have fork, FC, FO, FEF. Okay, so all the relationship here are vertical. And I indicate in the red form, meaning where the account, where your account is. You don't have account on the other provider, but you have account on the red, on the one in red. And depending on so for this, well, I can have ECE also, but you see the account is not in the cloud but in the edge. So then if I move to this edge, okay, and I need to do the so-called fourth party authentication, which is I'm the first party and my home provider E is edge is the second party and cloud is the third party and another edge provider is the fourth party. So I need to do the authentication with this guy, with this provider, which is fourth party authentication, which in turn go up to the cloud, through the cloud, and then go down to the edge to retrieve my home account in the home provider. And you move on to the, well, if you have three tier, you see cloud edge fork, and then depend on where the account is, where your account is. So it's three different combinations. Many to one, okay, you see CEC, which means that two cloud at the upper tier, and one edge in the middle at the lower tier. So the count is in the edge. Okay, and so you might move to this cloud, and you would need to retrieve the edge information, account information from the edge. Okay, so it's still vertical. And hybrid means that you have for example CCE, you got two cloud edge, and you need if you connect to this edge, and you need to do one vertical and then one horizontal in order to retrieve your account information. Okay, so you can see at least these are 24 combination, and if you allow more than three providers in the federation, there could be more than 24. Okay. But we don't, instead of solving 24 or more problems, we want to solve less problem. So we converge. So in the other way, so if we look at just the pairwise, okay, because when doing the federation, it's between two domains, two providers. Even in this, it's you also do you also do the authentic. I mean, you also deal with the issue between two providers. So we look at possible pairs. You can see that there are 6 pairs. One is cloud, edge, and fork, and then you have cloud edge, and then cloud fork, and then edge fork. So totally 6 pairs. Okay, and the 6 pairs, well, because among the 6 pairs, only this one, cloud to cloud federation, have been better studied, while the others are not well studied. So we, instead of working on this problem, we replace it with the MVC. So then it will be we remove this and then deal with this. So which is 2 MVC between 2 MVCs, but within the same provider, within the same edge service provider. Okay, and B is still the same between 2 edges, multiple MVC between multiple edge service providers. Okay, for example, AT&T and Verizon. Okay, and then the rest are the same, but we add another one, which is cloud edge fork. So it was 6, but now 7. So 7 problem we want to solve. And we look at if we divide them into this, you see here's the literature survey. These 2 pages show standard related. You can see that well, they mostly even though they try to honor the existing protocol, but in order to do the federation, they need to modify the existing protocols, okay, or add new protocol entities, which means that this approach of federation is not transparent to the existing protocol. You need to modify or add entity in the existing protocol. And in our approach, we try not to do so. We try to be transparent, leaving the existing protocol untouched. And also they solve they don't try to support multiple protocols. In our case, we try to support multiple protocols. So that's the difference. Another survey table, which is well, these are approaches that they simply ignore existing protocol. I mean, adopted in the cloud edge and fork. Okay, so and they try to have their own proposal, while not looking at certain these proposals will not be able to coexist with existing protocol. So certainly they are not transparent. Okay, and they don't deal with the multiple protocol either. In fact, they try to propose their own protocol. So in our approach, we try to be transparent. That's job number 1. And in order to be transparent, we try to we adopt the proxy approach. The proxy approach, which is I only need to add an entity between 2 service providers, then I can federate them together without changing their network or their protocols. That's what we try to do. And in order to do that, you need to have well, the proxy in between should play some proxy roles, and these are the proxy roles we develop at most 7. You will see that there are at most 7 proxy roles to be played by the proxy, depending on between whom you are trying to federate. Okay, and we also take the token-based approach in order to solve the mobility problem. Here, the mobility is not a connection mobility; it's the application mobility. So that you need to keep the state or transfer the state of the application server, not the connection level. Okay, And here we these are the type of problem we just mentioned, 7 of them, and they cover multiple scenarios. And here the protocol they try to support, where EPSAKA is the authentication protocol used in 3GPP in cellular system, and OIDC is the authentication protocol used in cloud. Okay, so you got edge authentication protocol for edge and for cloud, and also for 802.1x for fork. But because 802 fork system have the market is quite fragmented, so there are multiple protocol, including OIDC, the one used in the cloud is also used in the fork, and 802.1x plus PENA. So these three protocols are still competing with each other in the fork system. So we need to cover them because the market is so fragmented. Okay, so let's look at the 7 topics. Well, each is going to be short because of the time. And the first topic is intra-operator MECs with mobility support, where there are multiple MEC, but within the same service provider, within the same edge service provider, and we still need to support mobility so that they can move around. The UE can move around. So take this as an example. You see the UE here. It try to it connect to this MEC within, say, 5G. Okay, and then there's a MEC server here. Okay, so you see it connect here, and then well, the application server in MEC certainly have some state kept for this UE. Okay, and also it will issue a token to the UE, so the UE will keep the token, and then if the UE move to the target MEC from the source MEC, it will send the token, and then the MEC will know, oh, this is a visitor, and the target MEC will then connect to the source MEC in order to retrieve the state information. Okay, in order to retrieve the state information, so that the UE can continue to resume the state on the target MEC, and then continue to let's say pray the application. In order to do that kind of state transfer, okay, there are 2 approaches. Okay, in that token-based approach, one is that the token itself is a cookie, or the token itself is a state, contain the state. Okay, the token, the cookie transfer is the same idea as the the cookie used in web applications. So the cookie is just a string, and you pass to the application, a web application server, and the cookie value will be used as an index into a table to retrieve the state information for that client. Okay, so here you send the cookie value to the target MEC, and the target MEC will then send it to contact the source MEC and pass the cookie, so that the source MEC will send the state to the target MEC. On the other hand, the state transfer approach, which means that the token itself contains the state of the application, so that the target MEC does not need to contact the source MEC in order to retrieve the state, because the state is already in the token. Certainly, that will save some time, because you don't need to retrieve from the source MEC. So that will give you a better mobility support. Okay, and we did some tests. We did an implementation, real implementation, and with the in our test bed, and we can see that for this for our approach to use the token-based approach with the proxy. Sorry, no proxy here, because these are within the same edge service provider, so there's no proxy needed. But you can see that the authentication and re-authentication, the re-authentication with the target MVC is much faster. You don't need to log in again, so the time is much cut into less than a half. And also, as expected, the state transfer with the token contain the state is a better approach, so that you save some time in retrieving the state information, so that you can resume the service in a shorter time. The second topic, which is the MEC, multiple MEC, but in multiple service providers. So you have the inter-operator issue. And the difference with the previous problem is that now you need a proxy. You need a proxy because these are two providers, two multiple service providers. You need to federate them together. In the previous problem, there's no. It's only two MVC, but in the same service provider. For example, in AT&T alone. But now it's between AT&T and Verizon. And even the proxy needs to play some role in order to convert in between. But here, because both sides are homogeneous, they all play with the EPS, aka the same authentication protocol. So I don't need to play the monkey roles that we will see. We will need to do some monkey roles later for the other scenarios, but here no, because both sides are the same. So we don't need to pretend to be some entity in the proxy. No pretending. And so here's that proxy-based approach, where you can see on the left-hand side is the home domain, home service provider, where you have LTE call, and then you have MVC system, and then you have the foreign LTE call. Well, certainly that can be applied to 5G, and then foreign MVC systems. So, and in between, the proxy will need to do the two roles, but these two roles, they don't need to pretend to be someone. So so they can still bridge them together. I don't want to cover the detail on this, but you can see that they just bridge between the core network, and this will bridge between the two MVC. And there's some performance enhancement in doing so, but I don't have the time to cover these. What tricks we have done? We have done some prefetching in order to facilitate the re-authentication and also mobility support, and that improve the performance much. The third scenario is cloud edge federation, which is, I would say that this is probably is going to be very prevailing, say between Google and AT&T, between Google and your provider, your local operator. Okay, so I would say this type of federation is going to be very popular in the future. There will be customer to each other. And the difference with the previous two problems is that, now the proxy role become 4. You need to pretend to be, the proxy need to play some monkey roles to pretend to be some entities in order to federate them together. And here the two protocols involved, one is OIDC, one is EPS aka. As I said, OIDC is for cloud and EPS aka is for the edge with the 3GPP network. And you can see the tricky part comes here. You can see on the left hand side I have edge to cloud, which means that my account is in the edge, but I now connect to the cloud. So I'm doing the authentication with the cloud. So this is the UE. I'm connecting to the cloud. Okay, I need to be authenticated by the cloud, but my account is in the 3GPP network here. So what will happen is that I put a proxy here in between, and the proxy need to create two virtual role. One is virtual ID provider, identifier provider, and that is a defined entity, protocol entity defined in OIDC in the cloud. And so the proxy pretend to be one entity in the cloud. Okay. And on the other side, the proxy pretend to be virtual UE, okay, which is a UE but virtual, talking to the MME. Okay, MME in turn talk to the HSS. These are the protocol entity in 3GPP. Okay, including the virtual UE is also a protocol entity in 3GPP. And I don't have time to talk about their definition because it's well defined in 3GPP network. Same here that you have, it's all well defined. Identifier provider and RP, these are well defined, and UA. So I'm talking to this, and then this talk to the proxy. The virtual provider. And in fact, I don't know. The cloud provider does not know it doesn't need to know it's a proxy. Certainly, both sides agree to put a proxy in between, and then the protocol entity will talk to the proxy transparently. Okay, it's not, you don't need to change any protocol here or here. Okay, you just need to add one entity, pretending that you are a part of the cloud and you are also a part of the edge. Okay, so these are the two roles that we design in order to integrate them together. And again, now it's cloud to edge, which means that your account is in the cloud, but now you connect to the edge. Okay, so the UE is here and connect to the edge, connect to the 3GPP network, but our account is in the cloud. So then in the middle, in the proxy will then create two roles. One is the virtual HSS, okay, which is the MME will talk to the HSS, okay, and pretending this guy HSS is one of my guys, okay, and I'm talking to the proxy, so he doesn't know this is another guy, okay, and then on the other side it has a virtual user to the cloud, okay. You see, I pretend to be a ordinary user to the cloud, okay, to authenticate myself, okay. So then here you do the third party authentication, but here you do one part, two party authentication, second party authentication, okay. So you see, among these four roles, these virtual ID provider and virtual user, these are the cloud protocol entity. OIDC protocol entity, and these virtual HSS, okay, pretending to be an HSS, so that the MME will talk to this guy, and virtual UE. These two, they are the edge protocol entity. 3GPP protocol entities. So with these four rows in one box, well, these are not two boxes. This is one box, and one box playing four roles. So if the connection is from this side to this side, you play this role. If from this side to this side, from this side, from edge to the cloud, you play this role. Okay, so it depends on where the UE comes from. Okay, you play different roles. I mean, in different directions. Okay, so we are going to see these 4 roles in several times in the future's other scenarios. But as I said, there are 7 roles. So we have yet 3 more roles to see in the other scenarios. But for this scenario, these 4 roles will be enough in order to build the proxy. Okay. By the way, if you know the definition of the protocol background on 3GPP and OIDC, you will know why the logic behind the proxy rows. Okay. Okay. So, and again, we do some performance study and also security test to see whether the design has good performance and also can protect the system against certain type of threats. Okay, you can see that here if you do you can do authentication on OIDC or authentication on 3GPP, or you can do 2 of them together. So this and this concatenate together will be this. Or you can do the federated one. The federated one appears to be shorter than this. So this is shorter. This is shorter. So because you're doing a third-party authentication through the foreign service provider. You are not doing 2 complete authentication. No, it's not 2 complete authentication. It's going to be shorter than 2 complete authentication. Okay, the next scenario is cloud fork federation. Okay, and again, the difference with the previous scenario is that there'll be 4 rows, and well, there'll be some new rows, but some previous role is going to be reappear in this scenario. And here the protocol we deal with it will be different. So we still have OIDC here, but we are not having EPS AKA because that is for 3GPP network. Instead we have 802.1x. And here come that you have cloud true fork, which means that your account is in the cloud. That's your home, and you are connecting to fork. Okay, so here's 2 type of fork. One is OIDC fork, and the other is the 802.1x fork. And this is a user connecting to either to this or this. And there will be 2 kind of proxy. One is for OIDC to OIDC. This is OIDC to OIDC. So you can see here, I have virtual ID provider and virtual RP. Okay. Okay, and well, because both sides are OIDC, so you have, in fact, this one pretend to be this part, and this pretend to be this part. Okay, this pretend to be one of the protocol entity here, and this pretend to be a protocol entity here. And ID provider and RP both are the protocol entity in OIDC. Same here, that you have virtual AS authentication server. So virtual AS authentication server is a protocol entity in 802.1x, and RP is same here, that you have that you pray to the cloud. Okay, and on the other direction for fork to cloud, so the user is here connecting to the cloud, but the home provider is in the fork, either OIDC or 802.1x. So here it's this virtual ID provider, and then either virtual RP or virtual user. Okay, I think this is it's a typo here. It should be reversed. This should be this, not this. So there's a typo here. It should be this. Okay, and this and this. Okay. Sorry, this is not. This should be. It should be this. Oh, okay, yeah. This is correct. This is correct. ID provider. Okay. Yeah. But definitely this is not here. So, and the next scenario is the age to fork. Okay, and the different here, we got another 4 rows. I need to speed up a little bit. And again, you can see, you can check that they have, you got age to fork and fork to age. And now you have, well, we are not considering 802.1x here, just OIDC. So, and then with the EPS aka. So it's similar ideas. Okay, so I need to move faster. Okay, now we come to the universal process, the 7th scenario. Okay, the 7th. And you utilize all 7 scenario. But how? Okay. Look at this, for the cloud to, so this is a diagram that we try to see the relationship. For cloud and edge federation, you would utilize four role. VUE, virtual UE, virtual user at the home side, at the home provider side. And at the foreign provider side, it's going to be virtual ID provider and virtual VHSS. Okay, so you can see, you can track them. Each of them has some roles that they need to play. And if I look at just the where I connect to, I mean the foreign, the target foreign provider. If the foreign provider is the cloud, and I move from, let's say, another cloud, so it needs to play this role, and it's from another edge will be here. So the home side will need to play virtual UE to the cloud. I mean the home the foreign domain is the cloud. I mean, the foreign provider is the cloud. So you play this. So you can check, depending on the target domain, target provider, you can see what role you need to play. And there are four possibility here, because I got 2 for fork, one OIDC and the other one 802.1x. So I come up with this universal design that there are 7 row here, and there's a controller, and there's a relay. These are the relay to the providers. So for each provider, so the idea is here is this: if a provider wants to join the federation, regardless it is a cloud or edge or fork, I only need to add a relay, cloud relay, edge relay, or fork relay, and then connect it to my universal proxy or universal federator, and then it comes here. The controller will judge where you come from and where you are going to, and then I will create certain virtualized role for you. Okay, so I might create this virtualized role and then another virtualized role, and then to finish the job. Okay, so I will create one virtualized role for the source side, the source, and I create another virtualized role for the target. Okay, and all the logic is within one box, and the controller will then decide which two roles it would play in order to federate the source and target together. And to hardcode the logic, well, into a table, it will be something like this. You can hardcode it into a table, okay, from the foreign. If it's from the foreign side to the home side, it will be you look at this in a vertical column. It will be vertical column from the foreign side to the home side. That's usually what happened, because now your client or your subscriber connect to the foreign providers. So then it's in most cases you look at the columns, deciding so if it's a H2 cloud, so I need to create virtualized HSS here and virtualize user to the cloud. So you'll be this. Okay. So it'll be this. And if it's this, it will be this. Okay, fork to H or H to fork. So the logic is hard-coded into a table. Okay. And again, we did an implementation and testing to see how the performance goes. Well, it appears that it's not a major performance. It's not a performance bottleneck, because the proxy only take a small portion of time. Sometimes it take longer because the proxy role, especially for 802.1x, take a longer time due to spanning tree protocol, which take a longer time to converge. And we can downsize the universal proxy to just for fork-to-fork federation. So I downsized to fork-to-fork federation. Here there are 6 rows. 6 rows. Well, the same logic as the universal proxy. Now it's a universal fork proxy. So the entity I pray slightly different because of Penna, because I add Penna. Okay, so there are 3 protocols to support. I'm assuming the fork computing market has been fragmented into 3 major protocol standards: OIDC, 802.1x, and Penna. Then you come up with this structure. And again, the proxy role logic could be hard-coded into a table. Okay, so you can have this. And I skip the performance issue. Now I come to the conclusions. Okay, here we have designed 7 proxy roles, and then put them into the right position for right pairs of federated providers. And we support 3 protocol, 7 proxy roles, 3 protocol. Well, there's another protocol, Penna, but it's only considered in the last scenario. And 6 federated system. In fact, 6. Yes, okay. And each has certain proxy role played and supporting multiple protocols. And we take the token-based approach in order to support the mobility, and then we did some performance tuning and optimizations to make them better. Okay, so I believe that federation. Well, I believe pretty soon Google, AT&T, Verizon, and NTT, Orange. Those those operator and service and cloud providers like Google and Amazon, they will be renting capacity from each other. They will form a federation. We don't need to keep so many bills. We can just have one bill, and it's not just one bill that is beneficial, but also for the customer, they will be able to move around, get a service from either party in a more seamless way. Okay, and for that to happen, we need the federation to get mature, and we are proposing proxy as a transparent approach, and you just need to add some entities, protocol entity. I mean, some boxes in between the providers, and they can get federated together easily and transparently. And certainly, we need to do more study on performance tuning. I mean, performance study on how scalable. If I have not just a few UE, but thousands or tens of thousands of UE that are doing third party or even fourth party authentication, can the proxy what will be the capacity requirement on the proxy? Also, the proxy needs to be secure, because it might become more like a single point of failure. Okay, so it needs to be protected, and we have done some in our paper we have proved that for this security threat, the system is still be able to protect. Okay, protect itself. Okay, a future work will be extension on more protocols to support more scenario. As I said, there could be more than 24 scenarios, and the proxy, in order to be more scalable, it might need to be kind of hierarchical, with many servers and hierarchical. There might be more security threat to be analyzed. Okay, and scalability and fault tolerant issues. So I'd like to conclude here, and nice to have a talk here in TridentCamp. I hope you enjoyed the talk. Thank you very much. Bye bye.